Okay, function composition. So what does it mean? I don't know why it says inverse functions up there. We're doing that tomorrow. So what does it mean to compose functions together? Let's suppose we have some function f of x. We got some function g of x. I want to create a new function called f compose g. Okay. That acts as the composition of those two functions together. That little circle, imagine it's like a multiplication dot but hollow, like an open circle. It's an operation, and it's just a symbol for that operation. No, that's my cursor. Yeah.
Can it also be written like f with that
of g?
Yeah, of g of x.
We'll talk about that. Okay? So we've got f of x, g of x, f compose g of x. So here's how this works. Let's say I take the function g of x. Nice little function machine. It's got an input spout right there. It's got an output spout. Beautiful, right? X's go in. G of x's come out. Yeah? Yeah? Input, output. So let's suppose I chain that together with the function f. Such that as soon as g of x comes out of the function g, it immediately goes into the function f, and what comes out is f of g of x. Okay? That's the idea. That is composing two functions together. Okay? Well, the idea of the composition function is let's just create a new function. Its name is f compose g, such that x's go in and f of g of x's come out. Clearly more simple, right? To just create a new function that does the same thing as actually chaining those two functions together back to back. So remember all this from Algebra 2? Okay, composing functions together. The hard part, what's that? I have to go back and retake Algebra 2. Okay, so composition of the function. The hard part is figuring out what is the domain and range of this new function going to be. Okay? Well, clearly, if you're not allowed to put a number into g, you're not allowed to put it into f compose g, right? But then there's a second problem. What if g outputs things that f cannot handle as inputs? So those are the two things you have to consider. The domain of f compose g has to be valid numbers in the domain of g, but also has to be numbers that cause g to output numbers that are in the domain of f. And that is the complicated part we really have to analyze closely. Okay, we ready to do this? Let's do it.
So can you switch the order? Will that change?
It becomes a completely different function than if you switch the order. G compose f versus f compose g, totally different. In most cases, totally different functions.
So the first letter always is
Correct. Correct. In the sequence of events, when you see this notation, this f compose g notation, g is the function that x gets plugged into first, then the output of g goes into f second. Correct. If we switch the order, g compose f, we're actually plugging in f first, and then that output goes into g. Good. Okay, here's our example. They give us a function, f of x equals the square root of x, comma, x greater than or equal to 0. What is that there for? We'll talk about that. They give us another function, g of x equals x minus 1. X is greater than or equal to 1. And then they ask us to find f compose g of x. Okay, simple enough. Well, what are they doing with this comma, g, f of x equals the square root of x, comma, x greater than or equal to 0?
The domain.
Right, they're telling us the domain of the function. They're just telling us you're only allowed to plug numbers greater than or equal to 0 into the function f. Now, here's my opinion on this. What if they never told us this? What if that was never there? Well, how do I know what the domain of the function is if they don't tell me what the domain is? You look at it and figure it out yourself, right? You have to infer. You have to, there's an implied domain. So when you look at the square root of x, what's its domain? X is greater than or equal to 0. Okay? So to me, that information was a little bit redundant. It's not really necessary. But over here, that's a totally different scenario, because if they don't tell me what the domain of this function is, what is the implied domain of the function x minus 1? All reals. What is the shape of that? It's a line, right? But turns out this actually isn't a line, because they have restricted the domain of it. It's a ray. Okay? That is a graph that starts at the point 1, 0, and then shoots off into the positive direction. Can we graph that in our calculator? Yes, we can. Okay. So if you fire up your fancy schmancy graph calculator device, oh, by the way, I don't know if I told you this, there will be occasions where I don't let you have a graphing calculator on a quiz. Why? Because you use your brain more. Because there's a lot of stuff that calculator can do, and there can be times where I want you to prove to me you can do it without that calculator before I then let you have the calculator on future tests and quizzes. So there will be some quizzes where I don't want you to have a graphing calculator, but I will let you have a scientific calculator. So you might want to have both available at all times, like a TI-32, something like we use in OGT. I call those cheeky DPs. I stole the terminology from Bringo. The graphing calculators are your fancy smancies. Fancy smancies. Where do you get calculator batteries? You have to go specifically to a calculator battery store. Walmart, Kroger, where do you get any batteries? They're just AAAs. Yes. Awesome. All right. Okay. I have some, but like if you run out of batteries in the middle of the quiz, I can throw some in, but then you have to give them back to me. We're not supposed to let students take batteries. So.
Why?
Because it costs school money.
Oh, it's a school bag.
Yeah. Yeah, they're not mine. Okay? So how can we graph this? Well, there's actually a cool little trick we can do in the calculator. Everybody find the math button on your calculator. See that math button? Don't actually push it. I don't want to go to the math menu. I want to go to the second option, which is the test menu. So press second, press math. In there you see all kinds of equality and inequality symbols. So if I were to, I'm going to quit back to the home screen. If I were to say something like 2, and then go to that test menu, select, I don't know, pick an inequality symbol. Greater than. That's number 3. If I were to say 2 is greater than 1.7, is that a true or false statement? That is true. Yeah, like the alligator eats the bacon somewhere. So because that is a true statement, when I hit enter, my calculator outputs 1. It treats that as like an operation, as a mathematical statement where the output is 1. If I type a statement that is false, like 8 less than or equal to 5, what's it going to output? 0. 1 is true, 0 is false. Yes?
Is this saying, well, of course this isn't really a solution because in case there's no variable.
Right. I mean, what's 2 plus 2? Is that a solution? Is it a variable? It's a similar idea to saying 2 plus 2, right?
I mean, I just don't
it's a mathematical.
Getting your 1 and 0.
It treats it like the calculated program should treat that as almost like a mathematical operation, like addition, subtraction.
Okay.
Okay?
Okay.
Where, depending on the values of the numbers, it outputs 1 or 0. But they only output 1 or 0. Now here's how we can use this to our advantage. Go to graph, y equals. Go ahead and type x minus 1, hit graph, we see the whole line. Beautiful. If we instead type in parentheses x minus 1, I don't know why I said 4. Close the parenthesis. Then hit the division key. Then in another set of parentheses, type x greater than or equal to 1. Close the parentheses. What's your calculator actually going to do? Well, as it starts going through all of these potential points to graph, if x is greater than 1, what is this going to be? A 1. And clearly if you divide something by 1, does it change it in any way? No, so it's going to draw the line. But if x is not greater than or equal to 1, if x is less than 1, what is this going to be? What happens when you divide by 0? It's an error, and so the calculator doesn't graph anything. So, what you end up with is that red. That's tricky. Pretty cool, yeah?
Can you just type it in, or do you have to do the divide? Can you just put the comma?
You have to divide it. Because the calculator thinks it's a mathematical statement. You know, we're not writing fancy code. We're tricking it. It thinks it's just plugging and chugging numbers in for x. And some of those numbers are undefined, so it doesn't graph anything. Other numbers are just being divided by 1, and it graphs them as usual. You could technically multiply by it instead of dividing by it, but then you'd be multiplying by 0. So what you'd see is a horizontal line, and then you're red. This way, we're not graphing anything because we're dividing by 0. So it's a little trick, okay? But that's what that function looks like. It's the line y equals x minus 1, but only for x greater than or equal to 1. So it's a ray just like that, okay? Is it a function? Does it pass the vertical line test? Absolutely. Its domain is, you know, if I were to give you that picture, you should be able to figure out the domain. Oh yeah, that domain is x greater than or equal to 1, right? You can see it. If they don't tell you this domain, then they're implying that the domain is actually all real. So we have a constricted domain. All right, cool. Let's actually compose these together now. In order to find f compose g, we take the function f, which is the square root of x, but I replace that x with the entirety of function g, which is x minus 1. Does that simplify in any way, radical x minus 1? No, it does not. Beautiful. Okay, so now we got to figure out, even though the question doesn't ask us to, we're going to do it ourselves. What is the domain of this new function? Something besides ours. Pardon. Yeah, the domain is going to be x is greater than or equal to 1. That's great. How did you find that? So you actually looked at our new function to figure out the domain? How many of you do that, maybe did that, others do? You look at this function you just created and just find out what its domain is. Okay? That is a flawed method. You'll see why. Does it work a lot of times? Yes. Can I create for you a problem where that will not give you the domain? The next example will show you that. So I don't want to focus too much on domain in this problem. I just want to practice finding compositions. But it can help you. Worst case scenario, do just that. But I'll show you in the next example why we got to be a little bit more careful about that. How would you find f compose g of 2? Plug it in. So we got the square root of 2 minus 1. That's the square root of 1, which is 1. One of my biggest pet peeves is students who leave radical 1 as a final answer. Like, oh, that radical doesn't simplify. It's 1. I don't think I take points off for it, but I laugh at you. What is, first of all, let me, what is f compose g of 0? Can't do it. Undefined. Why can't you do it? Well, we never actually get a negative under the radical. Because, let me ask you this. In this composition, which function are we plugging 0 into first, f or g? So let's focus on g. What is g of 0? No, it's not. It's undefined. It is not negative 1. G of 0 is not negative 1.
Oh, yeah.
0 is not in the domain. So therefore, G of 0 undefined. So you can't even input it. See there? That's the trick. This is undefined, not because you get an imaginary, but because 0 is not even in the domain.
And also, if you have negative x, if it's not a number like a negative number, negative x, it's still a function.
I don't follow.
Because you can have a negative of a negative number.
Negative, yeah. Right.
Radical still, so it's still a function. Radical of negative x.
Where do we have a negative of a negative in this?
We don't. It's just if we have negative x.
Oh, okay. Just because you see negative x doesn't mean the number's negative.
Yeah.
This is what you're saying. Right. That's, yeah, okay. All right, let's go on to the next problem. Given f of x equals x plus 2, g of x is 4 minus x squared. Find f composed g. They also ask you to find g composed f. Oh, this isn't the example. It's another example. It's the next one. All right, this one's also not that bad. Let's find f composed g. So we take the function f, which is x plus 2, but I replace that x with 4 minus x squared. So if we simplify this, we get negative x squared plus 6. Beautiful. Make sense? Total review of Algebra 2 so far, right? I don't want to do all of these. Pick one of those numbers, 0, 1, 2, or 3. 2 sounds great. So f composed g of 2, that's going to be negative 2 squared plus 6. What is negative 2 squared? Negative 4. We're not squaring the I didn't say negative 2 squared, I said negative 2 squared. There's a difference. There's negative 2 squared, but then there's negative 2 squared. And those are different things. Right? Look, you have to listen to how I say it. Negative 2 squared, negative 2 squared. Right? Totally different. Negative 2 squared, negative 2 squared. Totally different. Totally different. Come on. No. It is very, very important. Is the negative being squared? No. So when we plug 2 in, we square the 2, that gives us 4. Then we take the negative of it, and then we add 6. So the answer is 2. Well, if the original function had been written like this, it would be positive. And in fact, it would be silly to write a final answer like that, because are you ever going to get a negative out of that? No. So if you ever have something like this, you might as well just write it x squared plus 6. Just get rid of that negative altogether. But that wasn't the case. We have a negative 1, right? What's the coefficient of this x squared term? Negative 1. So you have negative 1 times whatever x squared comes out to be. So that's the key. Now, we could have done this individually. We plugged 2 into which function first? G. So what's 4 minus 2 squared? 0. We immediately take that 0, plug it into f with 0 plus 2. 2. Right? Yeah, that's what we did. We got 2 by actually using the composition function. Now let's find g composed f of x. So now I want to take the function g, 4 minus input squared, and what is my input? X plus 2. So now if we want to simplify that down, we got to FOIL, distribute that negative, combine like terms, we get negative x squared minus 4x. Well, I mean, as far as presenting a final answer, there's no, depending on the context of the problem, we usually don't present final answers in factored form. Okay. Feel good about composite? Do we need to plug a number into this one? I don't think we need to do it. It's pretty good. Now here's the funny thing, like if, let's pretend we are computers. You have to square something, then take the opposite of it, you gotta multiply something by 4, then you gotta add those things together. That's 4 operations. Whereas in this form, you add something, you square it, and then you subtract. It's only 3 operations. This is actually more efficient.